Hey, botanists, welcome back. So today we are continuing on with a shoot. So today we are continuing on with a shoot. Remember that term shoot refers to the entire above ground portions of the plant. We've already seen how the stem develops and how those little leaf primordia make. Today our focus is really going to be on leaves. So anything that develops from a leaf primordium is a leaf. It might be hugely modified. And I think you're used to seeing a lot of diversity in leaf shapes and forms just from walking around the world and noticing things. Let's just start out by drawing a very kind of boring leaf. Let's see here. Forgot I gotta share my screen with you. So we're gonna start out with just a simple kind of boring leaf. Before we get to my leaf, in all these drawings, these models, right, I'm gonna have a stem. We're gonna kind of largely ignore the stem because our focus is on the leaf. The first leaf I'm gonna make is kind of just a boring little leaf like that. Remember, any place where a leaf attaches, that's going to be a node. So here's a node. And remember, leaves are always going to have those axillary buds in that leaf axil. Right, so you already know this. We've already covered this in other parts of the course. Right, there's that little axillary bud. Well, let me add in a couple layers, right, and talk about this leaf and how we can understand it. So first off, let me give you the name for that little leaf stalk. The botanical name for a leaf stalk is the term petiole. Maybe you've heard this term before, maybe you haven't. So that's just the term for a leaf stalk. When you were sectioning celery, you were actually sectioning through celery petioles. The often kind of wide expanded part of a leaf is called the blade. Although there can be variation in what those blades look like. The edge of this blade, right along, is what we call the margin. And I've called this leaf kind of a boring leaf because I think it is. Another way we could describe it is really a simple leaf. And what this term means, simple, applied to leaves, it means that that blade is just one continuous piece. And you can see that's what I've modeled here in my drawing, right? Our blade is one continuous piece. It's not divided up, right? So a simple leaf could look like that. It also could look, say, a little bit something like this. There's my stem, there's my axillary bud. Well, now let's have some changes with my leaf. Still gonna have a petiole, but our blade might be what we call lobed. And you've probably seen leaves like this. I know from where I grew up, I often think of things like valley oaks and blue oaks, right? They have these simple lobed leaves. Right, it's still a simple leaf because the blade is one continuous piece, but there's areas where the blade is wider and areas where the blade is narrower. So that's one variation that we can see on sort of the theme of a leaf. Let's see a few more. Well, not all leaves are going to be simple. Some leaves are going to be what we call compound. And in a compound leaf, that blade is going to be divided into segments. So the blade is going to be divided into segments that we call leaflets. And there's two basic varieties of compound leaves out there in the world. There's what we call pinnately compound leaves and palmately compound leaves. Let's start with pinnately. So in a pinnately compound leaf, that leaf is going to be divided into leaflets or segments arranged like a feather. And let me model for you exactly what I mean by that. So there's my stem, there's my axillary bud. I still have that petiole coming off, but my blade is going to be divided up into these segments. Each one of those segments we call a leaflet. And those leaflets are arranged like a feather. Now, the other variety of compound leaves are what we call palmately compound leaves. And as that name implies, our leaf is going to be compound, but it's going to be like the fingers on your hand. So there's that stem. There's my axillary bud. There's that petiole. But all my leaflets are going to be radiating out from a single point. And it's something like a Himalayan blackberry, if you're familiar with those. So that's one way we can categorize leaves, the way we can really learn about their diversity. Let's learn a few more terms, because what I'm really trying to give you is a vocabulary, right? A vocabulary that you can use to apply to all the different kinds of leaves that you can see out there in the world. So in addition to talking about how leaves are simple or compound, we can also talk about what their leaf margins look like. And we're going to see three basic leaf margins. The first is what we call an entire leaf margin. And you can think of an entire leaf margin as a smooth leaf margin. Because what that means when we look at that margin, that edge of the blade, it forms a smooth surface. Now, the second variety of leaf margin that we can see out there is what we call a dentate leaf margin. Now, you should think dentist, same word right here. A dentate leaf margin is going to be toothed. And so when you look at that edge of the blade, there's going to be teeth there, right? It's not going to be a smooth surface. Instead, there's going to be little jagged teeth. Well, we've got one third and final margin out there, and that's what we call a crenate leaf margin. And these tend to be a little bit less common. These are lobed leaf margins. And so there's kind of like little waves right along that edge. So that's one way we can categorize leaves, right? Based on what their margin looks like. Another thing that we can look for when we look at leaves and try and understand their diversity is we can look for something called stipules. And stipules aren't probably something you've seen before. What stipules are is they're paired leaf appendages. So they're leaf appendages, kind of like leaf accessories. They're always in pairs, and we're going to find them at the base of the petiole. So right at those nodes where that petiole is attaching the leaf to the stem is where we're going to find our stipules. And let's just illustrate this. So there's my stem. There's my axillary bud once again. And let me draw just a boring leaf. Well, sometimes when you look at the base of those leaves, you're going to see these tiny little things that might themselves look like leaves. If they're in pairs, right, and they're right at the base of that petiole, you're probably looking at stipules. So sometimes stipules look like leaves. We'll probably eventually in here see some stipules that are modified for defense. Sometimes the sharp things you can find on plants are actually from stipules that are modified. Sometimes they serve more of a protective function. We'll probably see some diversity in lab this coming week when we're out there in the world looking for stipules just in kind of their shape and their form. So looking for stipules is another way that we can compare different leaves and kind of make sense of all the diversity that's out there in the world. Well, there's one final way to categorize leaves and think about leaves, think about diversity out there. And that's by looking at leaves and comparing their leaf venation patterns. So leaves, like stems, like roots, are going to have veins of vascular tissue. And there tend to be two basic patterns that we see out there when we look at nature. Now, some leaves are going to have what we call parallel venation. And in parallel venation, the veins are parallel, right? They're forming parallel lines. If I draw just a section of leaf, the veins are going to form parallel lines running through the blade. Each one of those in red just represent a separate vein. Right, those are all my veins. They're forming parallel venation in a leaf like this. Well, it turns out that parallel venation is going to be characteristic of monocots. And if you grow monocots, things like corn, if you grow gladiolas or iris or lilies, right, you've seen this before. Well, the other major venation pattern that we see out there is something called netted venation. And we'll illustrate this one too. Let's draw just a little section of the blade here. What we're going to see in netted venation is that there's one large vein. You've seen this in the world. We call the midvein. And then the other veins are going to branch off of that. So I'm sure you've seen this before out there in the world, right? We've got this highly branched network of veins running through the blade. And it turns out that this venation pattern, a netted venation pattern, is going to be characteristic of our eudicots. So it's not just features of the roots or the stems, you know, how the vascular bundles are arranged that we can differentiate, right? Sometimes it's these morphological characteristics that we can see with our eyes as we're walking out there in the world. All right, that's it for today. We'll be seeing real life examples of this and getting to practice this soon. Bye, botanists.